It's a great day. We are on a long final descent to Boeing Field next to Seattle after a great round of golf in Banff with my friend Charlie. Just love the scenery in this part of the world. Yes. Oops, what happened here? Okay, AP off. I have control of the aircraft. Quick assessment. No fire or smoke detected. Engines sound okay. Can't feel any unusual vibration, so that's good. No loss of control. Everything feels solid, so I don't think we hit anything. Just seems like there's no power to the panel. Okay, so let's look at the emergency procedures. No fire or smoke detected, yes. Autopilot disconnected, confirmed. Interior master switch is off. Battery disconnect off, confirmed. APU off, yes, confirmed. Engine generators, both off, yes, confirmed. Ignition on. DC battery power switch to emergency. Okay, now I can see the emergency instruments working. That's good. Okay, let's call this in. Squawking 7700. 59 Mike Echo, pan.
59 Mike Echo, what's the nature of your emergency and state your intentions?
We have what seems like a total electrical failure. Requesting vectored approach to Boeing Field, 14 right, 59 Mike Echo.
59 Mike Echo, maintain current heading.
Heading 180. Assessment shows no fire and we have emergency power. That's working. So this is not a life-threatening situation, but we do need to get on the ground quickly. 59 Mike Echo.
59 Mike Echo, roger. Vectors to KBFI 14 right. Continue heading 180, descend and maintain 3000. How many souls on board and what's your fuel status?
59 Mike Echo, heading 180, descend 3000. We have 8 on board, about 45 minutes of fuel. 59 Mike Echo.
59 Mike Echo, do you need to stop on the runway or can you taxi back to the gates?
We expect to be able to taxi to our gates. 59 Mike Echo.
59 Mike Echo, roger. Expect vectors to the ILS 14 right.
ILS 14 right. 59 Mike Echo. Oh, hi Charlie. We're just a bit busy up here at the moment. What's up? Good grief, you want a what? No, I heard you the first time. You want an emergency battery instrumentation tutorial for this aircraft now? Seriously? Oh well, okay, I guess now is as good a time as any. Fine, buckle in. So, welcome Mr. Brown and all of you listening in. Glad to have you drop by for this emergency instruments tutorial for the AirSim3D C-560XL. Since you asked for this, good timing by the way, we'll take a look at the emergency instruments available in this aircraft so you know what's available should such an emergency situation arise that would require the aircraft to be flown on emergency battery instruments only. To begin and summarizing what we learned in our last tutorial, this aircraft has both a main and an emergency battery, and we talked quite a bit about how to turn it on and use it in the last tutorial, so if you have not already done so, please review it. We always ask that you look at our tutorials in their numbered order, as each one builds on knowledge gained on previous ones, and that way we don't bore you by repeating things. Okay, so as you saw earlier, we turned this switch to the emergency position. As a result, the aircraft changes to a lower power state with only a small set of emergency instruments. This is by design and authentically modeled, but while it looks scary, it does, especially at night, the aircraft can be flown quite safely. Now the aircraft flies in a lowered powered state with only a small subset of all its instruments when the switch is in this position. But be advised, by design the power will only last about 30 to 45 minutes, so you do want to land as soon as possible. And to recap, in this state the pilots will have the following fully functional instruments: the standby HSI and VOR, checklists from the norm button on the MFD, the left side engine instruments only, below it the gear position lights. Now of the two clocks on either side, only the pilot side works, But notice below that the COM panel on both the pilot and co-pilot sides function. You will tune COM and nav frequencies using the RMU, but you will listen to ATC or hear or mute speakers and marker sounds by selecting the buttons on this panel. So there are two differences over there. The emergency stack also includes a lighted, functioning DC voltmeter, although if you notice, it now has a small LED to light up and conserve power, and it's not backlighted as it would be if the panel were operating under main battery power. There's a little attention to detail there. And finally, this small RMU for COM1, 2, and VOR 1 and 2 nav tuning. It's a bit complicated because it's so small, so let's take a look at how this 100% authentically modeled and lighted instrument works. First, pay very close attention to this little caret to tell you what you are tuning on that radio, and also to this number to tell you whether you are tuning channel 1 or 2 of what is being tuned. So in this case, the caret is pointing to the COM, and we are on 1, so the white number is the active COM1 frequency, and the blue number is the standby frequency for COM1. That is not COM2 frequency, by the way. You will change the blue standby number for COM1 with the lower part of this dial. When it is set as you desired, use this shift button in the vertical mode to move it up to become the active white COM1 frequency. And that action will flip what was white to the blue below. This little custom RMU is fully capable of tuning COM1 and 2 and NAV1 and NAV2 active and standby channels. So you interchange channels 1 and 2 by using the same shift button, but now in the horizontal mode. So now with it displaying 2, you can program COM2's white, active, and blue standby frequencies, just like we did for COM1. Now, to be able to instead change and tune nav channels, click the top of the dial, tap the top of the dial to change modes from COM to nav tuning. Now notice how the character designator is now pointing to nav. And to change its active and standby frequencies from NAV1 to NAV2, just follow the same method we discussed for COM. So to set nav frequencies with the dial and the vertical shift as well, and flip between NAV1 and NAV2 with the horizontal shift button. Yep, we acknowledged. Operating this little unit takes some getting used to, but here is another example of extreme authenticity modeling in this aircraft. Well, you asked for it, you got it. But keep practicing and you'll get it. So moving on, there are a number of things that still work under emergency power, but you really don't get active visual enunciators on emergency battery power. As examples, the engine reversers work, but you will see no upfront enunciations. So just wait for over 3 seconds after deploying them to set reverse power to ensure that they are first fully deployed. Similarly, the AP works. But since the main PFD has no power and the AP statuses cannot be seen, the AP really should not be used in emergency situations. Notice the angle of attack gauge works, but it's in passive mode on emergency power, so no electrical readouts. Other critical systems continue to work, like flaps and gear and the yoke and the pedals. They all continue to work, and their failures are caused by other things like hydraulic system failures, so that continues to work too. But the bottom line, folks, is that if you are in emergency battery power, you really should be trying to land as soon as possible. No rush, but as soon as possible. Now, for a very challenging flight, try flying at night in bad weather on emergency instruments only. The glow from those real 3D lights cast by those working instruments in a dark cabin is kind of scary. And they are tuned and custom lighted beams that change with the aircraft conditions, so it's very cool to fly like that. All very authentically modeled and labeled. We have no fake 2D photoshopped lighting here. It's all very real, all very challenging, and all very authentic. So, pilots, Declare emergency and see if you can make it. Remember to breathe and not let your hands shake so much. See you on the flip side. Bye.